All right, good evening, everyone. My name is Kris Rivera. I am a senior software developer at a local company in Roslyn called MBO Partners. We basically make tools that make it easier for independent contractors and enterprise clients to do business with each other. And a lot of overhead reduction of paperwork and taxes and everything that makes it easier so that independent contractors can just simply get to work and the enterprise clients can hire them for the work. I also am a 50% managing member of my own company, DK Wares, and we make video games. We make mobile games, and one of the most recent games is Taxi Town. It's on the Android and iOS market, so feel free to take a look at that. And you can follow me at KK Rivera on Twitter. And this is my talk on Intro to TypeScript. So first off, let's start with defining the correct terms here. So a lot of people commonly use the word JavaScript, but it's actually, the standard is called ECMAScript. ECMAScript was first introduced in 1997 as a way to standardize the previous implementations of JavaScript that had no standard to them. And so editions 1 through 5 were published over the subsequent years, but at a slightly irregular interval. So the one version that most developers who are called JavaScript developers are using ES5. If you look at this, swath of code, you probably recognize it. Lots of vars. This is some node code with requires and some callback function and whatnot. So this is what some, just ES5 code looks like. It should look pretty familiar. So ES5, again, what I say was that it's what most developers write with who are JavaScript developers. You should know strict mode, immutable globals, array extensions. There's a lot of features from ES3 to ES5. ES4 was actually skipped or abandoned in favor for ES5. And the big advantage why most JavaScript developers write in ES5 is because it's already supported by every modern browser. I don't know if you want to call IE11 modern anymore, but it's still IE11, Edge, Firefox, Chrome, Safari, Opera, and also server runtimes. There's a couple other ones I never really heard of when I was looking this up, but definitely Node 4 is a much older version, but it fully supports ES5 along with the Chrome mobile browsers for Android and iOS. So moving forward, 6 years later, ES6 was introduced, or also known as ES 2015, and it was published in, you guessed it, 2015. Pretty standard naming convention there. But this was the first of many additions to come as a promise to annual upgrades for the standard. So they definitely, every year they wanted to put out new upgrades, new features to the standard. And here we had huge gains with let and const variables, classes and modules, arrow functions. I'm sure everyone has heard of or seen or probably used promises for doing asynchronous actions. Lots and lots of really good features. And the browser support is still very good. It was out in 2015, so current day. Everything basically that was in ES5, that was supporting ES5, is supporting ES6 as well, except for IE11. That's the desktop, but I don't think anyone is really too sad about that one. And Node 4 as well doesn't fully support it. It supports it sort of, but that's why you have to go to like Node 8 or Node 9 or so on. And similarly, it's mostly supported on Chrome for Android and Safari for iOS. But who doesn't want new features? Again, the promise for new features on an annual basis continued on. So we have ES 2016, ES 2017, soon ES 2018, if not already. But if you notice, per an annual cadence, the feature set is much smaller. So for ES7, aka ES 2016, you have the exponentiation operator, which indicates that, or means that you don't have to use the math.pow anymore. They have a numerical operator for that. It's the double exclamation marks, as well as the array prototype includes. It's a very useful feature. And then ES8, a very important, but again, a single type of feature, was the async await, which lets you handle promises very easily in a very programmatic and very linear way when you look at the code. But again, as I noted, It's a smaller feature set as in comparison from ES5 to ES6 because it's just a year gap for them. But here's the problem though. Which browsers support it? Only the bleeding edge browsers support the latest standards of ECMAScript. So we look at this and say, well, what do? How do we use these new features? Do we just exclude browsers from our feature set? Do we alienate our users or force them to use new browsers? It's not a great experience, there's something not right here about this. So enter transpilers. So transpilation is the process of taking one language and compiling it into another. So transpilers will take ES6 or higher code and transpile it down to ES5. So you still get the feature set that you want or trying to use or the newest features, and you still get the browser support. So some of these most popular transpilers are Babel or Grunt or I don't know how to pronounce that. It's either Babel or Babel. I'm not sure. But then we have, Grunt and Gulp are two build systems, but they also support transpilation as one of their build steps as well. But it seems a little, you have to upgrade the standard and use the new browser and so on, and then you have to transpile it. So, I mean, there's an evolution to the ECMAScript standard. You see, ES1 was very old, ES6 is great, and so on, better standards. But again, this is all a very arduous process, it feels like. So, I mean, there has to be a better way. And I think you guys all know what that might be. It's TypeScript! TypeScript, everyone! So, TypeScript was first released in 2012 by none other than Microsoft. Now, I know a lot of people, there's a lot of stigma around Microsoft software for a long while, especially Windows. I see a lot of Mac devices here, not too many PCs out there. But TypeScript is fantastic. It is an open source project, so you can just go download it, fetch it, try it out, compile it, run it, and you can also contribute to it. And just so that you know, it's not just TypeScript isn't some like one-off, like a few people in their basement are using it language. Google's Angular adopted it in version 2 and continue to support it, and if not, embrace it and promote it in later versions up through 6, which is their current. And VueJS version 2.5 and up support TypeScript as well. I don't want to give away what's coming later, but you'll see that. And so basically, TypeScript is actually a superset of the latest version of ECMAScript. The later version of TypeScript that you have supports and has all the features of the latest version of ECMAScript. But you say, oh no, what about browser support? Well, actually, no browser supports TypeScript. But this is on purpose because the TypeScript language comes with a TypeScript compiler, which will allow you to compile it down to whatever version of ECMAScript you want. If you want full compatibility, compile down to ES5. If you want some of the later features of ES6 in the browser, you can compile it to ES6. If you want to compile it to ES8 or whatever, then by all means you can. But this is fantastic because we still get the feature set that is all of ECMAScript, plus we get all of the features of TypeScript on top of it. So we have compatibility, we have a powerful language, and we have all the features that come with ECMAScript, so that everyone knows and loves. So here's some of the features. You have basic types and assertions, interfaces, classes, and inheritance. So people who are Java developers or have been Java developers or C++ or C# developers will be in very good company here. You'll feel very comfortable here because this is a lot of things that they took from object-oriented programming languages and put it into a very script-like language still. So functions, namespaces, modules, generics, and even decorators. So there's a lot more. I don't have enough time to go into all of those. So today, as an intro to TypeScript, I'm going to go over basic types and assertions and interfaces for you guys today. So let's start with basic types and assertions. Again, you will be Java developers and so on will be very familiar with what I'm going to go over here. But so here are the types that TypeScript provides and supports for your use. Boolean, number, string, array, tuples, and nulls, any's, enums, void, never, and object. So there's some things here that are not in the Java language that were added for TypeScript purposes because they make more sense in a scripting language sense versus some things that you will easily recognize, such as Boolean, number, string, and array, and so on. So let's go through a few examples of these. So this is how a Boolean is defined and asserted. The colon, and then after the variable name says, I'm asserting that this variable is of this type. And that ensures that anything on the right side of the equal sign has to abide by that type assertion. Moving on, we also have here numbers, or you can have them in decimal, hex, binary, octal, but again, the assertion is the important thing to indicate and restrain what's on the right side of the equal sign. So again, it's the colon and the number, or the colon and the Boolean. So I'm going to go through these. String is very straightforward. Colon, string, you can only have a string on the right side. Colon, so now we're going to go through arrays. Arrays can be defined in two ways. You can do what the array is and then do the braces afterward, or you can use the array object keyword and do a templating angle braces and put the number inside. So those are both two ways, but again, that asserts that you can only have an array of numbers. Tuples are something that I think a lot of object-oriented developers have struggled with, made classes for, and something that was made very easy in TypeScript. Simply, you define the colon, you say that I want a square brace of something that's a string and a number, and then when you initialize it, you have to initialize it with, I think you all guessed it, string and number. You get it's okay to assign the hello and 10 versus 10 and hello. That's an error. You will get a compilation error, which is something that JavaScript developers have been wanting for a long time. So that's something I'm giving away a little bit why TypeScript is so awesome. And then finally, undefined or null characters or null types is very simple. Colon undefined, that's something from JavaScript. Everyone knows what an undefined thing is versus something that is null. Null is an object, but in here, null has a specific type as well. So you can assert that this variable will only be null. And of course, you're seeing all these lets. You can do const as well. TypeScript does not allow you to do var. Var is something from ES5, and var is not allowed anymore. You have to define it as a let or a const by the ES6 standard. Any and enums and voids are pretty easy. Speaking about vars, an any assertion is basically saying this variable is a var because it's a var args. You can say I am a number or I'm a string or whatever. You can just assign it and assign it and assign it as whatever you want. It doesn't matter. But it's a very slippery slope to doing that. I would highly advise you never to do that unless you really have to tell the compiler, just let this be an any just in this case, because then you're negating the whole purpose of TypeScript. You're not really giving it a hard type that you know and expect and want compilation errors to come up for if you just say any everywhere. So it's very important that you use this very sparingly. An enum, again, another object-oriented construct, is just an enumerated list of items but with a string name associated with it. So you just define it with the enum variable or the enum name right before the variable assignment, and then you can assign that, or you can assert that C, the variable, is going to be an enumerated number or of a color, so you can just use color.green to pass that around. You can also, you're not stuck with 0, 1, and 2. You can define what these numbers are in your enumeration. Very easy, very simple. And then finally, void. Void is something that a lot of JavaScript developers are used to when you just have a function that just performs an action and doesn't return anything. Well, you can assert that this function cannot return something. If you try to return something, then it's going to give you a compilation error right in line and tell you you shouldn't be returning something because this function is expecting a void type, which means you don't return. So it's pretty awesome how you can assert the types on these variables and functions. And then finally we have never and object. So never means that you don't even get to the end of the function. So void means I get to the end of the function, but I don't return anything. Never is something where it's just intended to basically, I think this is one of the only cases is where you're just going to throw, or you know you're going to error and it's not going to get anywhere. So that's when you use the never assertion. Again, you have that at the end of the function definition, and you declare and you assert that I'm never going to return anything, or I'm never going to get to the end of this function. And finally, object. Object is the thing that most people who have done JavaScript are most familiar with. It's just JSON notation. So here we can assert that we have a function create with a variable parameter O, and it can be an object or null. So that's something else that you can do in TypeScript, that you can do union operators, which say it can be an object or a null. So let this thing be one or the other. So when you go to create prop and you pass in an object, which is JSON notation, that's okay. You can do that. Or if you pass in null, because that's what the assertion told the parameter to allow, you can pass in null. But if you pass in a number like 42 or a string or a Boolean, anything else other than those two things, you will get a compilation error and your code will not compile. All right, so now types are done. Let's go to interfaces, where this is a very powerful thing that was introduced in TypeScript. And this basically lets you define custom types so that you can restrict parameters or outputs to be as such. So the first thing here is, let's take a look at this example. So this is a function called print label, and it has a label object as its first parameter, and we're saying I want this label object to be an object that at least has a label property that has a value of string. Okay, so we have to have the label key, and it has to have a value of string. So if we jump to where it says let my object, we have an object that says size of 10, but we also have the key label, and it has a size of 10 objects, so that's a string. So when we say print my label or print label with my object, this is good. But how do we make sure that, how do we use an interface to make this a bit more eloquent, a bit more reusable, and a bit more well-defined in a certain part of your application? We can use the interface keyword. So at the top we have the interface labeled value, and we say with the curly braces out, it's how we indicate what an interface is. We say we have a label and it's a string. So it's the same thing that we just had back here. Again, label string as the parameter, but now we're just taking that and storing it as an interface. But then when we go to the function print label, we don't have to redefine that this thing is an object that has a label and a string. We just use the interface there as our type assertion. And then the rest of the code behaves exactly the same as the other example. Okay? We have optional properties that we have on. So I just showed you a required property. Now, optional properties are notated with the question mark colon. So that means that this is an interface that will be for an object that can either have a color or a width or both or none. So each parameter is optional, so they can be defined or not in it. But if you do define something that has that optional parameter, it has to say color or it has to say width. So it can be one or the other, but nothing else. So again, here we have the function create square, and the config is using that interface as its assertion. And we say, if we jump all the way down to the bottom, the inside of the function is not so important. We have a my square, we call create square with it, and we pass in, notice, an object with just one of those parameters defined. We could pass in one with no parameters, an empty JSON, but we couldn't pass in one that was like color 1 or width 1. That would give you an error because that doesn't abide by the interface. And finally, we have read-only properties. So that means that we define them as just with the read-only keyword inside of the interface. And what that means is that we define it once, but we can't assign it another value afterwards. So we have our let point, and we have our interface point, and P1 is asserted as a point. We define it to match the interface, and then if we try to assign X afterward on P1, then it just will not work. It will error at you, and that's because that's how we define the interface, because we only wanted it to be a read-only parameter. So now we have types inside of interfaces. So the first type is a function type. So the way we define a function type inside of an interface is simply with the open and close parentheses. It looks just like the function signature that you would have if you just chopped off the function keyword. But you have basically first parameter and second parameters are strings, and then the last parameter, the return of this function needs to be a Boolean. So the way we use that is, let's say we have a let variable called my search, and we assert that it's a search function interface. And when we define it or set the equals to it, we have to abide by that interface. So the source is a string, the substring is a string, but notice the return is returning a Boolean. We're saying if result is greater than -1. So that's what the interface is asserting inside of its function type. We have indexable types, and so basically what that allows you to make is how you want to constrain what a JSON object looks like. So where this is saying is that we have an index that is a number. So what object has an index that's a number? An array, right? So that's why this is an interface string array. And then the value, this afterward, is the string. So we're asserting that the index is a number and that the value is a string. All right? And so we use that interface. We assert my array is a string array. And then when we assign my array to Bob and Fred, which are both string values, and the index is definitely a number, this is valid. This is good. And we can also fetch variables out of it and whatnot. Now, let's look at read-only indexable types. These are exactly the same thing as the previous example, but you just can't assign to it after the fact. So we have that read-only string array. We have that my array that's typed as read-only string array assigned to Alice and Bob. And then on the next line, we try to assign index 2 to Mallory, and you're going to get an error. You don't get an error because of index out of bounds. You only get an error because the type doesn't work. At runtime, you'd get the error, but at compile time, it would show you can't assign anything else to this array. And finally, one of the biggest and best and most powerful parts of TypeScript is using interfaces with class objects. Again, people who have had object-oriented programming or classes or worked in it will be very familiar here, but basically I have a clock interface. The interface says that I can have a variable called current time that is a date object, and we have a function called setTime that receives a variable d that is also a date. And so we define the class below called a clock. We use the keyword implements to use the interface to constrain how the inside of the class looks like and how you know it will behave on the outside. So it has to implement current time, that's a date, and it has to also implement setTime, the function. Notice it's not just the signature, it's also the actual execution and implementation of the inside of the function as this.currentTime is equal to d. And then it has a constructor as well as all the ES6 classes have. Last but not least, extending interfaces. You may want to reuse base interfaces and branch off of them. So we have the interface shape, and it just has a variable called color. That's a string. And we also have the interface square. Now you use extends keyword to extend an interface to basically gain the properties of the interface that you're trying to extend from. And it is, we just add a side length to it. And then here, if you look at where let square equals that angled brace, that's another way that we can assert the type of an object as well. It doesn't have to be :square. It could be angled braces, square, and the object as well, because everything can have a type in that manner. And then we are able to have access to a square's color and a square side length. And finally, how do we gain all these superpowers also, or most easily use them? I'm sure a lot of JavaScript developers here already have heard of or are already using Microsoft Visual Studio Code. I know, another Microsoft product. What's going on here? the world is falling apart. It is honestly with the fastest speed, and it's becoming the best editor for both JavaScript and TypeScript editing. You get fast compilation errors that just show up in line. I know Angular is a bad word to use in these meetups, but it's definitely the preferred TypeScript editor for Angular developers as well. But VS Code is extremely customizable and extensible, and is used or has a lot of plugins for VueJS as well. And these are just a few of them that I just listed as some of the most popular, but there's a huge list of Vue.js extensions or plugins that VS Code supports. And you can get that at code.visualstudio.com. And that's what we use at my job and at home as well. And it's our preferred. So that's it. Thank you so much. Please follow me at KK Rivera if you like this. And thank you so much.